So we have our what's this? Dilute standard NaOH.
Right. You can tell me. I will be typing because I still have the answer on my written sheet.
So we have our 50 mils of sodium hydroxide.
Perfect.
NaOH, and we also have 50 mils of 2 molar. What is that? CH3OH. Is that literally acetic acid as well? Okay, they're both acetic acid.
Yeah.
Well, hopefully we've got the constant molar for this as well. Okay, and we have. What else do we need to know? Okay, degrees are changed, so we have from 22 degrees Celsius to 33.7 degrees Celsius.
Perfect. I'm in agreement.
Now we're going to make our equation.
Yep. So what are we going to write?
So NaOH plus CH3OOH. So you can assume that there's going to be some water.
Love it.
Next. Yeah, I'm just going to write this myself quickly. Actually, I'll write it out at the end. Doesn't matter. Okay. So H2O plus, and it did the exact same things last time? Yes, it is. Well, it's different, but oh, it's the same. Okay, so then we're gonna have water plus CH.
Oh, you just turned on my
Let me just start again. So we have NaCH3OO minus.
Ding, 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 ding.
And
yes.
2. Okay. So,
correct. And you're
we
very
balance
lucky.
in the same way. We're going to put a 2 in front of the water. But do we not need to for this one?
Balance.
Oh no, there's no 2.
Lucky. There's no 2.
There's no 2. Okay, that's right.
It's not barium hydroxide with the 2 right here. There's none of that. That's why I say you're very lucky. This question is beautiful because you have no balancing to do.
Excellent.
Done.
Very good. Next, we're going to.
What's step 1?
We figure out our heat transfer.
Perfect. So I'm going to write it as if I was doing it in an exam.
How many joules did we lose?
Ding, 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 ding. All right, transfer. Let's do this. So what am I going to do?
So we're going to write our formula, yeah?
Yep.
So we have a Q equals M delta T. Do you like writing it this way instead of delta T? Do you just find it easier to remember? Remembering.
Sure, I can write delta T if you want.
Because it's like writing delta T.
Like, but I can't write delta T. Like I can't find delta, the symbol on this. I can
find of course.
But I don't have it on this. But I can just do this. All right.
Yep.
So let's do this. We can do this.
I just remember delta always meaning change.
Yep.
And then just whatever it's put next to is changing.
Correct. That is correct. So
now we're going to find out what our temperature find out our mass of whatever it is. So our mass is 100 milliliters.
Yep, I'm agreed.
Do we want to put that in? Do you want to put that? We could put that in liters if we wanted to.
This step you don't
have. You don't have to. Okay. Next we got our specific heat capacity of our water.
Yep, perfect. Check.
Then we got our change in temperature, which is from 22 to 33.7. And we get, let me see.
I've got it on my piece of paper and I'm waiting.
Times 4.18. And we get 4,890.6.
That's not what I got.
Do you not get that?
No, that's not what I got. I got 4,639. Let me just redo my calculation.
That's strange.
Yep, you're right. 4,800.
That's strange.
Right, that's joules, remember? So, next step. Is it endo or is it exo?
It is a endo, so we have gained some
Really?
energy. We have, yes.
Yes, let's
It's not a
look.
minus. Next step, we're going to.
No. I'm looking at your question right here. You went from 22 to 33, so it's not endo.
Oh, but why have we? This does not compute. So
Wait, let me double check something. Give me 3 seconds.
temperature has increased, but that's strange.
Okay, yep, you're right. Don't worry. Don't mind me.
How,
So
why is that endo though? Like that's
because
strange.
it has increase in temperature.
Yeah, but like why would those two, an acid plus a base, ever be anything but exo? Which is a bit
The
weird.
acid depends on the base.
But these two are pretty much the same as what we had before, and that was exothermic. That's a bit weird.
Alright. What's next?
Now we're gonna find our actual what's it called? Our moles, our molarity times.
Wait. I'm just reading my textbook quickly, and it says that if you're increasing in temperature, your Q is still going to be negative. We've got a discrepancy.
We do.
Let's double check. Yep, so it's endothermic. Interesting. So let's continue. We've got our plus. What are we going to do after this?
We need our molarity. So
Step 2.
so we have
Okay.
a number. We want to figure out a number of moles.
So how are we going to do that?
We're going to get our molarity times our volume. So we have number of moles. We have which concentration are we going to use? I mean, which 1.5 molar. Okay, so 1.5 times our
wait, where did you get 1.5
liters.
from?
Wasn't it 1.5 molar? Oh, so no, it's 2
No,
molar.
it's
Okay,
2.
2 m.
It's 2.
Okay, yep.
2 moles. Yep, 2 moles times our volume.
Yep. Our entire volume. I'll just have volume for that one.
Yep. And we're going to get N, which is equal to. Yep. Do you agree?
Moles. Yep. 1.2. And then next we have that. Since we've got that now.
So now we're going to find out the official.
Yep. Heat capacity per. So then we put our joules over our moles. I mean, over our moles.
So delta H is equal to Q on N. Do you agree with me?
Yeah.
Perfect. So we're going to do what you said. We're going to do 4,890. And we're going to divide that by 0.1. Do you agree?
Yeah.
Cool. And what are we going to get as an answer?
Let me see. 48,900.
Perfect. And remember, that's joules. So step 4,
Joules.
she's pedantic, so joules.
Now we just change it into kilojoules. Divide by 1,000.
Yep.
So it's going to be 4,890. Oh no, it's just 48. Okay, yeah, it's 48. Divide by 1,000.
Cool. Done.
Oh yeah, I was cool. Joules. Now I'm gonna write this myself.
Go for it. No worries.
1 second.
No worries.
Just
Here, can you see it if I put it like here?
yes, I can now.
Go for it. And then I've got my next questions.
Okay, we've got to do them quickly.
Oh, good. The most important thing is you're understanding what's going on.
Yep. Is there models to describe the what acids and bases look like structurally?
You
Like
mean
there is for other what's it called
you mean for like organic reactions when you
yeah
see
for like organic
there is
compounds.
there is definitely a reaction for what happens. There are models. Do you know those little stick figures with balls that you get to play with for organic?
Yeah.
Yeah,
Yep.
there's exactly the same. So you do actually get to see what happens. How
Because
does that?
acids and bases are considered organic, aren't they?
No.
No? Okay.
Remember that acids and bases, I mean, not acid, organic chemistry is when you've got an organic molecule, and an organic molecule is defined as a molecule that contains carbon and hydrogen. So
Yeah.
I would agree with you about the acetic acid. So CH3CO minus is a carboxylic acid. So yes, I agree with you. That would be part of the organic chemistry. So you're partially correct. So in this
Yeah.
situation, acid, yes, is part of the organic chemistry, but sodium hydroxide definitely not, because it has no carbon. It's
Yeah. Some
carbon.
of them would be though.
Me?
I think I think I remember seeing what acetic acid looks like structurally.
Yeah, you would for
Um,
organic.
yeah.
All right, how are you going?
Don't acids have that OH group on them or something?
So this one has a C double O bond between those two.
Yep.
And then this carbon's also got an OH.
Yeah.
All right, you ready?
Nearly. This takes.
Okay.